we go. Today we're continuing the idea of what we were doing yesterday, which was graphing inequalities. Today we're going to graph a systems of inequalities. So look at this warm-up. We've been doing this all week, solving for y, but today we're doing it with an inequality. Yesterday on our notes, which if you missed them, they're in the blue bin, but the very important thing we can't forget is if you multiply or divide by a negative, you have to flip your inequality. Okay, let's see if we do that today. So since we've been doing this all week, we know to get y by itself, I need to get rid of the x. How do I get rid of a minus 2x? Opposite is plus 2x, and remember, it goes in front. Please be careful right here. When you bring this down, it's not just 5y. There's a minus in front. So minus or negative 5y less than the 2x goes first, the positive, so plus 20 goes next. All right, so that's first step. Move the x by doing the opposite, put it in order. Step 2, divide. To get rid of the number in front of y, we divide by the exact same number. Negative 5, divide by negative 5, divide by negative 5. So now, I'm left with y. Reminder from yesterday, when we divide by a negative, this inequality, this less than sign, will now have to flip and become a greater than sign, because I divided by a negative. So look, I'm highlighting it so you see what I'm talking about. So again, I flipped it because I divided by a negative. Now 2 over negative 5 is negative 2 over 5 x. 20 divided by negative 5 is negative 4. So you put minus 4. Okay. Go ahead and make sure your name is on it. You pass it to the front, and I'll pick it up here at the front. Double check your name is on it, please. And then we're doing this. All right. It's, Here we go. Notes, graphing systems of inequalities. Now look, everyone was here yesterday, right? So we learned this yesterday, how to graph inequalities in shade. So today is not something brand new. We're just doing it more than once. Okay, if you do it twice, it's called a system. So these systems of inequalities, please. So let's lock in up here. Okay, so you shouldn't be a Chromebook doing anything at all. So you can close it if it's distracting you. Now, a couple things. I need you to draw this real quick because it didn't print very well. But it says to shade above is greater than or greater than equal to. This is supposed to be underlined right there. See that little blue line? Okay, right here. Make sure you underline that. And that's when you shade above. Greater than or equal to. And then for below, it's less than or equal to. You'll see that? And then the solid line is if it's greater than or equal, less than or equal, right? Underlined is when it's solid, but the dashed stays the same. Dashed is if it's not underlined. Okay, since we did this yesterday, I'm going to do this a tad bit faster. Just a tad. So here we go. I have a inequality. Y is by itself, so it's mx plus b. M is 2, b is 4. If m is 2, that means 2 over 1. Right? We know invisible math. Whole number is over 1. Okay, so before I graph it, looking at that inequality right here, see how it's underlined? Does that mean it's going to be solid or dashed? What do y'all think? Solid. Underlined is solid. And what is this symbol called? Is that greater or less? Greater, so that's going to be above. So if it points right, it's greater. If it points left, it's less. Greater is above, less is below. So now let's plot some points. mx plus b. What do I graph first? The m or the b? B. B is 4. Let's put a point at 1, 2, 3, 4. Then I'm going to rise over run. Rise 2, run 1. Okay, that's a slope of 2. 2 over 1. Okay. So with your straight edge, you can make a nice straight line. Remember, we just said it's solid and shaded above. So, solid line, no dashes, and lightly shade above. Okay? Above is just literally up from the line. Okay? So if you got this far, that was yesterday's notes. Today, the only thing different is we're going to do it again. Okay? So I'm going to change my color. So on this one, the slope is negative 1 over 2. The b is negative 4. Okay, we're on that second line now. Same graph, second line. So we got negative 1/2 is the m, b is negative 4. Now, look at that inequality symbol. Is it going to be solid or dashed? It is underlined, so that's solid. My pen is malfunction. 1 second. And then since it is greater than again, that's above. So we put a point at the b value, negative 4. 1, 2, 3, 4. And then our rise over run is negative 1 over 2. It's negative up or down? Down 1 over 2. Okay. And again, we're doing a solid line. And it says to shade above. So what you're going to notice is when you're shading, you're going to end up with a double shaded region. Okay. One area should be like darker because it has 2 shadings, right? In my picture, I used red and blue. And if you know anything about colors, red and blue makes purple. So I'm going to make this a purple. Okay. So if I were you, I would make this a little bit heavier of a shade. So you know the double shaded region. Y'all ever heard of a Venn diagram when you have 2 circles and they overlap? What matters for us today is where do they overlap, okay? So if you're looking at my screen, I don't care about just red. I don't care about just blue. I don't care about no shade. I only care about the double shaded red and blue, purple if you want to call it that. That's what matters. Okay, and that's what it says right below this. Okay, it says for a system of inequalities, a solution is any point in the intersection of, underline this, two shaded regions. Not just in one of them, it's got to be in both. Okay, both. Okay, and it says where the shading overlaps. Both inequalities will be true. Okay. Now, let's test some points. Okay. There's some points here, and you're going to tell me yes or no. Is it in the double shaded area? Double, both. Okay. Well, 0, 0. If I plot that on here, is 0, 0 in the double or just in the red? It's just in the red. So is it a solution? No. It's not in both. It's only in one. 0, -3 down here. Again, it's not in both. It's just in one of them. 4, -4. 1, 2, 3, 4. 1, 2, 3. Again, not in both. It's just in one of them. 1, 1. Also not in both of them. Okay? That's a lot of no. No. Flip it over. Okay, let's try some more examples here. Make sure you got this down. But all 4 of those points ended up in the red area only, not in the blue, not in the double, not it. Okay? All right. Ready on the back? Anyone study the front? On the back. Now, what's weird about this equation is that y is not by itself. It's not a slope-intercept form. Now, on yesterday's notes, we definitely talked about how to do this. We did it on our warm-up today, so let's do it again. I need to get y by itself. So first, I need to move the x, right? How do I get rid of that positive x? Minus x on both sides, right? Minus x, minus x. It's going to go in front. Bring down 2y. Now, the inequality doesn't change. It's still a less than. We're going to have negative x first and then minus 2 second. Cool. And then to get y by itself, that coefficient 2 has got to go. Let's divide everything by 2. Now, dividing by a positive 2 does not change your inequality. It's going to stay less than. Cool. Now, negative x over 2. Does everyone know a negative x? Okay, it's like a 1. There's no number. There's a 1 there, right? So negative 1 over 2 is going to be my slope. And what's negative 2 divided by 2? Negative 1. Okay. We have successfully got y by itself. So now I know my m in front of x is negative 1/2. I know my b out here is negative 1. Look at the inequality. It is not underlined. Is that solid or dashed? Dashed. And it's a less than sign, so is that above or below? Below. So, mx plus b, I graph the b first, the negative 1 on the y-axis right here. And then I'm going to use that slope. Negative 1/2 means up or down. Negative is which way, up or down? Down 1/2, down 1 over 2. Use your straight edge protractor to make a dashed line and then shade below. Dash, 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 dash. All right, so make sure everyone catches up. All right, ready for the next one. Now, the next one is not y by itself, right? It has y minus x. I'm going to have to get rid of that minus x. The opposite, plus x, right? And remember, it goes in front of the coefficient. So I have y less than x plus 3. Okay? And remember, if it's just x, we know that x means 1x. So the slope is 1 over 1. The y-intercept is 3. Can we graph that? Let's first figure out, is it going to be solid or dashed? There's no underline, so it's going to be dashed. And again, we know less than is below. So starting at our b of positive 3, okay, and then the slope is 1, up 1, right 1, 1 over 1. Go ahead and make a dashed line. Dash, 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 dash. All right, and now, actually, I forgot. I forgot on the last one. We got to shade that thing. So you forget, you always do it. But on both of these, we're shading below, right? So on the red one, my first one, one second. Here we go. So this one is shaded below, and the other one is also shaded below. So below the first one, below the second one, they overlap only right here, okay? And when they overlap, they do not overlap on these dashed lines. So only in the shaded overlap, not the dashed lines, okay? So the question is about these points. 0, 0. Is 0, 0 in the double shaded region? So look, 0, 0 is only in one shaded area, my blue one. So that's gonna be a no, not in the double shaded region. Okay. What about 0, negative 3? 1, 2, 3, right here. I don't know if you can see it. Okay. Right there. But yeah, that's in the double shaded area. Okay. So that's a yes. We finally get a yes. It's in the both shaded regions. Okay. Now, what about 4, negative 4? So 1, 2, 3, 4. 1, 2, 3, 4. What do y'all think? Yes. Again, it might be kind of hard to see, but it's right here. So yeah, that is another yes. But what about 1, 1? 1, comma 1 is right here. It's only in the blue shaded area. That's going to be a no for me. Okay. Do y'all see how this works? If it's y by itself, graph it correctly, shade it. Only the double shaded area is a solution. Okay. Now there's one more example I want you to try, and we'll check it. Okay. So I'll give you 3 minutes. We're gonna try this next one, and then we'll go over it real quick and be done. So everyone's trying this one right here, and then at the very end, you're gonna give me one solution point. Here we go. Alrighty. So the first one, the M is 4, the B is -3. It's not underlined, so it's dashed. It's greater than, so it's above. You plot -3, and then remember 4 means 4 over 1, right? So up 4 over 1, dashed line, and shade above. And then on this one, the slope is -2 over 1. The y-intercept is 3. It's underlined, so it's solid. It's greater than, so it's above. The b is at +3, and the slope is -2, so down 2 over 1. Make yourself a nice solid line. going to shade, it says above. So where do they both overlap? In this area, not on the dashed line, but it does include this solid line part, okay? Now, where could a solution point be? Well, anywhere in this shaded area. I'm gonna pick, again, there's many answers, but I'm gonna pick this one right here, okay? So when we're counting this, it's gonna be 0, 1, 2, 3, 4, 5, 6, 7. 0, 7 is for sure in that double shaded area, okay? Well, I'm going to pass out your assignment. This is Monday. You can get started early today if you're not working on missing work corrections. All right. Wait, sorry.